Okay, equation of the tangent line yet again. So let's rewrite this. So this should be cosine of x over 4 all squared. So x over 4, don't let that deceive you. It's just the number 1/4 times x. So if I need the derivative, so I'm going to bring the 2 down, make it to the 1 power, carry that along. Now I'm going to multiply by the derivative of the cosine, which is negative sine, carry the x over 4 along. And now I'm going to multiply by the derivative of x over 4. And so the derivative of 1/4 x is just the number 1/4. All right, so that's the derivative. So now I want to plug in pi. So y prime of pi, so that'll give me 2 times, well, actually, let's put these two together. So I've got a 2 and a 1/4, so let's just make that a 1/2. And so if I put in pi, I get cosine of pi over 4, which is root 2 over 2. And if I put in pi, I get sine of pi over 4, and I got that negative I'm carrying along. So then I get negative 1 over 4. So that's my slope. All right, so that's m. I'm going to put into my equation of my tangent line. So I also need to find the y value. So the y value is me putting in pi into this function. So again, it might be useful to put the squared on the outside. So this is like saying cosine of pi over 4 all squared. Well, that's root 2 over 2, you know that. Square it, so I get 2 over 4, so 1/2. All right, so then put together my point, which is pi 1/2. So I get y minus 1/2 equals negative 1/4 x minus pi. So that's my equation of my tangent line. All right, so this is randomly placed, but it's something I'm told I need to cover. It has nothing to do with chain rule, but I want you to memorize this formula for half-life. So y sub 0 will be the initial amount, and m is the number of half-life years. So let's just go and dig in. It's a formula you're going to want to memorize. So they say there's a 100-gram sample that we start with. Okay, so that's our y sub 0. And it has a half-life of 1,200 years. Okay, so that means m is 1,200. So I can put together my equation here. So I have y equal 100, 1/2 to the t over 1,200. So now I'm ready to go and see what they're asking me for. So they want to find when, so a time, when it'll decompose to 20 grams. So that means I want to set this equal to 20 and solve for the t. So first I'm going to divide by 100, so I get 1/5 equal 1/2 t over 1,200. Then I'm going to take the ln of both sides. And the reason I'm taking the ln is the ln property says if I've got this exponent up here, I can bring it down in front. So that's t over 1,200 ln of 1/2. Remember, I'm solving for t. So I'm going to say, let's divide through by this ln of 1/2. And I'm left with t over 1,200, and then finish off by multiplying by 1,200. I would prefer this kind of answer than a calculator. That looks wonderful. All right, last one. So this one, they're not telling me how much the sample is. So we're just going to keep it as y naught. And then this thing here is the half-life years, so that's the m. So we can put it together, y equal y naught, 1/2 t over 900. All right, so it's saying I want to find the time, right? How long? Time again. Will it take to decompose to 75% of its original amount? So that means we're taking 75% of the y naught. So what we're going to put here is the 75% of the y naught, and then equals y naught 1/2 to the t over 900. Okay, I see that I can cancel this quantity of y naught because it's not 0. There's some amount there. And then I want to, so let's just simplify that. And I get this. And then we're back to the same situation. We want to take the ln of both sides so that I can bring that that exponent, the t over 900, down in front. So I did 2 steps in one there. So then I'm going to divide through by the ln of 1/2. And then I'm going to multiply by the 900. So I get t is equal to 900 ln of 0.75 over ln of 1/2.